Christian Iverson, or you might as well call me Mr. Iverson since I'm going to be teaching you this lesson today. And I'm here to teach you how to do this Criss Cross method. Because we already know how to write formulas and such with all the ionic compounds and such. So why don't we use this Criss Cross method? And what exactly is this Criss Cross method? I'm glad you guys asked. Basically, what you do is, for example, take let's just say sodium. Let's just take a phosphate, for example. All right. So that would be PO4 minus 2. All right. And now let's add another element, such as let's just go with sodium. All right. Which is Na plus. So PO4 minus 2, or 2 minus, however you want to do that, and Na plus. So, Criss Cross method. Basically, you take the oxidation states, the minus 2, the plus 1, take that, crisscross, like that. And to make this whole formula work, you are going to make sodium phosphate, which is Na2, since the 2 goes right there, instead of there, and goes PO4. And the reason why this 4 does not change is because it's permanent. It just stays there. It's not going to go anywhere. It's stayed, it's trapped forever, prison, what do you want to say? But the 4 is always going to stay there. So sodium phosphate, Na2PO4. So now, we got the first part, the easy part, squared away. So now, to make this even a little more harder, we're going to add a little challenge to this. Because we all know we have to have a challenge once in our life, or every once in a while. That's how we succeed, right? So alright, the first compound we are going to add is hydroxide, or you can just call it hydrogen oxide. Most people are going to call it hydroxide, so yeah, just say that. Makes more sense. And then we're going to add an element, a solid, perhaps, aluminum. That's going to be plus 3. Why plus 3? Because it's special. Very special. One of the rare solids that gets that plus 3. And I don't know if any other element has that plus 3 factor, so don't quote me on that being the only one. But yeah, it's plus 3, and it's not really confusing. It's like the only one that most people know. Alright? So we're going to crisscross. Circle this little sucker, circle that little sucker, then crisscross. And then we're going to make aluminum hydroxide. Now watch very closely of what I'm about to do here. Alright, so you see the OH, and you see the 3. But what you see differently is this little parentheses. And for all those beginners, they're going to like, oh my gosh, oh, what the heck is this parentheses? I'm going to explain it right there. Glad you asked. So, hydroxide, or hydrogen oxide, is already a compound. It's not an element, it's already a compound. And you can't just crisscross, an element to that to here. I suck at speaking, so I'm just going to demonstrate you right here. You can never have like, an OH3, because, that will never, ever, ever exist. Ever. Write that down. So, and to explain this for all those new people in chemistry that have no idea what I'm talking about right here, so capital letter right here, another capital letter right there. Alright? Nothing is going to add with the capital letters. It's going to stay in its own area. It's not going to be, OH2 or OH6 or OH36,401.6254. Basically what I'm saying is that has to be isolated. Alright? It's got to be isolated. That's the best way I can pretty much explain it to all those beginners right there. So there you have it. Aluminum hydroxide. Criss Cross.